Okay, I'm going to go over test 2 with an eye on test 3, and hopefully you can pick up a few things about test 3 and make some correction in your understanding, because that's pretty much the main goal of learning. Okay, so the first one is a question about integrity. Most everyone said they have integrity, and that's maybe the most important question on the exam and most of your in your life. So the second one was a little disappointing in that I didn't get 100% on this. State the least squared regression criteria, and this is on page 57, stated, for example. And then the one thing you should note is that there should be squared terms on these expression, but the scanning on the computer or on the copy machine cut it off. Number 3, you might think about seeing this again. We always talk about this epsilon at being the error random variable and what the assumptions are. And you should be able to say how to check any indications it's not okay, and it is okay. One thing you need to include indication that assumption is okay of something about the p-value on the normal probability plot. So make sure it's bigger than 0.01, then it's okay. And if it's less than 0.01, then maybe it's not normal. So the mean equals 0 is automatic. Standard deviation sigma is constant. Plant residuals versus each predictor, and you want a random scatter about 0, and indication it's not okay as patterns or drifts. Here's one where a lot of the data points are above 0. Here's a graph where they're drifting or narrowing down or getting smaller or larger. So you may say something along those lines. Number 4 is a question about interpreting. And by the way, this is an example of a sample estimate of a regression, whereas the betas up here is our linear model, the model that we build with the epsilon and the betas. This is our sample result with the BIs and numbers here. So the coefficient for B3, notice is not a beta, 22.61, says that everything else being equal, or none of the other variables increase, make sure you include that. Then if you increase years by 1, the SAT score will go up by 22.61. So that's basically everything on this page you should look to see again. All right, going on to the backwards elimination method. People did a pretty good job explaining the backwards elimination method. The one thing is that it's not final. You need to use the partial F test to have some stronger evidence whether you can eliminate those. R squared can assume, remember, it's a positive or non-negative number, so it's 0 to 1. R squared is 1 if it lies on the data line. The only one that you have here is that's positive. We cannot say it's weak. We have to look at the R squared or standard error. It might be that that's 0.005 is just in a ridiculous units. For example, we might be measuring our hair in miles per hour growth. So just because it's a small number doesn't necessarily mean that it's weak, that the correlation doesn't tell you anything about the correlation coefficient. Everyone got number 9 correctly. I like number 10 as a problem because you have to understand how the sum of square error and regression sum of the sum of squares total, and the sum of squares regression divided by sum of squares total gives you the R squared value, and how that if you take and then the coefficient here for the weight is negative 7.03. And that A, as you take the coefficient divided by the standard error, gives you the T, and so you can get that. The one thing, the hardest, maybe the one that's missed the most with CCC, where you have to take 2 times the CDF to get the p-value for this. So since you don't have the other data points, you can figure out from the t-value what the p-value will be. Okay, so going on, I like that problem. It's not likely I'll include it on exam 3. It was on your practice as a practice review problem for a past exam, but it's unlikely, I say. It doesn't mean it won't be on there, it's just unlikely. Most people did pretty well on checking the assumptions or describing it. The bonus one is that if you good to get bonus points, extra credit if you recognize that residuals for years, because that's not part of our model, additional predictor might say, hey, we should add that prediction. Y hat is you plug in the values. Some people use the different digits, which might give you a different answer. Remember, it's y minus y hat, the observed value minus predicted value. You can get a negative residual. Number 13, I tried to tell you. I thought I told you, but anyway, there was going to be a problem on extrapolation. This was that problem. Your x equals 150 is beyond your x range, and so you want to avoid extrapolation. You could tell the city planner what the height would be, but you also say we would be very skittish about using that data. Number 14, maybe a little to remind yourself that proportional means that y is equal to k times x and that the y-intercept is 0. So here you're testing whether beta naught is 0 and the alternative if it's not 0. And you calculate the t-value. And since the p-value is, from the t-value is close to 0, you can reject. And so strong statistical evidence that it's not proportional. One of the nice things about writing down the null and alternative hypothesis, after you do all these calculations, you're like, okay, what was I testing? So you can go back and look at it. 90% confidence interval, remember it's estimate plus or minus the multiplier times the standard error. If it's one-sided and you want to say something's greater than a number, you use a minus sign because you want to give yourself some wiggle room. And if it's less than something, you want to add on the multiplier times the standard error. In this case, you're doing both. If you want to kind of remind yourself here that you subtracted, so you have the beta 1 bigger than the less than 1, and beta 1 is less than, if you had a one-sided on that side is less than. So anyway, you calculate it as being 10.5 less than beta 1, less than 12.1. And you need an interpretation. On average, we are 90% confident each floor adds 10.5 to 12.1 feet to a building's height. Remember, data is in context in the statistics class. You always want to put in the statistics class. A lot of people did 16 and 17 correctly. A random variable, whereas the confidence interval is on average, and you give the mean or average on there, and then you just something that you interpret it. For example, a city planner might use prediction interval for the next 70 foot building, and she might use the confidence interval for a series of building that are going to go in. All right, so just saying a few things about the exam for test 3. I'd encourage you to look over the first page and make sure you can understand that. The other part is to make sure you can distinguish between when you're asked for a model, the linear model, that would be with betas and epsilon, versus the sample estimate, the linear regression estimate. That's where you have beta hats, BIs, or the actual numbers for that. Overall, I think the class did pretty well on the exam. Your score probably may be disappointing your score, and the scores were a little lower, so I'll have to probably adjust that towards the end. Remember, on my syllabus, I reserve the right to be more generous. So if you had like a 79%, I can't give you anything lower than a C+, but I might say, hey, this person maybe deserves a B- or a B in the class. So, and because of the situation with the way the semester has gone, I might, it's likely, I think, and I don't know how much. I can't give you a confidence interval at this point as far as how much your grade will be boosted from that.